Okay, welcome back. The next thing we're going to talk about is section 2.6. 2.6 is called something like combinations and composition of functions. So this is going to be different ways to, well, combine functions. But before we do that, there's a brief sort of setup piece, which is about finding the domain of a function using algebra. So we'll call this finding domains algebraically. So we found domains using the graph, right? Looking for all the different x values where the graph is defined. We did domains, right? Looking at just like individual pairs, coordinate pairs, xy pairs, right? The domain are all the different x values. So what we didn't do yet is actually like on a function where we have a formula, right? Sort of an expression, some sort of equation looking thing, finding the domain, finding all the x values that work. And the real key here is that most of the time, most of the x's will work with the kind of functions we're looking at. So there's really like 3 key points. And so point number 1, I guess if I said there's 3 of them, we should number them, is the domain for any polynomial, right? So the different polynomials we've been working with for a while, for the most part, any x value put into a polynomial is going to be fine. It's going to sort of go through the motions and it's going to give us some sort of number out of it. We're not going to run into any kind of like math issues. So the domain for any polynomial is what we would call all real numbers, right? AKA, as an interval, it's just going to run from negative infinity to positive infinity. All the possible numbers are fine for any polynomial. So if we're looking at domains and we see a polynomial, just right off the bat, without having to think too hard about it, we're just going to say all real numbers work. The second thing is look for rational, fraction type functions, and the restriction is the denominator is not allowed to equal 0. So if we're talking about the domain, if we have any kind of a rational type function where there's some sort of formula, some sort of variables in the denominator, in the bottom of a fraction, we need to make sure that we don't include any x values that make the denominator 0. We have essentially done this already, right? We did restrictions for rational expressions way back in chapter P. It came up also when we were doing rational equations, right? Anytime we sort of have any of these fraction type situations, we always have to make sure that we don't get a 0 in the denominator. So that's still true. The next thing is we're not allowed to have any negative values under an even root, right? So that would be square root or like 4th root or 6th root or on and on and on. So any of those even roots, we're not allowed to have a negative number under them. So if we have a root as part of our function, we just need to make sure that for the domain, we're excluding any values that would make whatever is underneath that radical 0. So let's run just a couple quick examples. So our goal here is find the domain. So example A, let's say. So how about f of x is x squared minus 8 over x squared minus 4x. So maybe I have a function that's kind of like this. the key here, right? So this is rational. This has a denominator. And so for the domain, we need to make sure we have the x's where whatever this denominator is, right, x squared minus 4x, is not equal to 0. So all the x's where that doesn't happen are good to go. So it's going to be easier for us, right, to actually find the handful of trouble coordinates, the handful of values that don't work, rather than trying to say, okay, what are the values that do work? Well, most of the values will work. We don't need to do anything with the top, regardless of what's up there. It could be the exact same expression on the top, x squared minus 4x. It could just be x squared. We're not going to try to reduce it. We're not going to try to do any of the stuff that we did before. It doesn't matter. All we're looking at as far as the domain is what is the bottom without making any changes, and what would make that 0. So for us, this is just a little bit of a quick factor, right? So we'll say x squared minus 4x. This is like a GCF kind of style, right? So this would mean for us x times x minus 4 can't be 0, so that's going to get us, right, two individual values. That means x itself can't be 0, right? Or this x minus 4 is not allowed to be 0, right? This is just a quick little guy. If we sort of add 4 to both sides, what we'll see here in particular, right, is that x is not allowed to be positive 4. So finding the domain really just amounts to, in this case, right, taking that denominator expression, setting it equal to 0, and finding the values that would make that happen. We're trying to exclude those values. So the domain for us here, we can kind of notate a couple different ways. So we can say, right, all x's except x equals 0 or 4, right? You could kind of do something like that, do more of a word version, right? Or you can do as an interval, right? What we're going to do is we'll say the domain of f. So it's all the values except for 0 and 4. So that's going to mean interval style, right? Would be negative infinity up to 0. We'll use our parentheses because we're going to jump over it. We'll use our u for union. So we'll pick up on the other side of 0 with our other parentheses, and we'll go from 0 to 4. We'll use our parentheses, right, because we're not going to include it, and then we'll jump over it. We'll pick it up again on the other side from 4 to infinity. The homework, I believe, are looking for answers that are in that form, this sort of interval form. Test or quizzes, I'm fine if you just sort of notate it slightly less formally as just x can't be 0, x can't be 4. That works, that's fine. Totally up to you. If we do another example, right, maybe I've got g of x is just like 6x cubed minus 4x squared plus 19 or something, right? So this just is a polynomial, right? This is a polynomial. There's no fractions, there's no roots, right? Polynomial check. No fractions, no roots, no problems at all. So our domain here, without even having to do any kind of real algebra work, we can just sort of jump right into it and say the domain is just going to run from negative infinity to infinity. It's just all the real numbers. And we're good to go. Let's do one last one that uses a root. So maybe I've got something like, FGH, right? That's kind of how these things normally go. What could we put under here? 2x plus 6, something like that, square root. So our domain right? The idea here, our restriction is, so the domain for h, what we need is 2x plus 6 greater than or equal to 0, right? No negatives underneath the root means we have to be greater than or equal to 0. 0 itself is fine, right? I can have the root of 0 is 0. That's just a thing that can happen, and that's okay. So what I'm going to do is just kind of quickly do a little bit of algebra right. We'll kind of solve this for the x. We can treat this, right, greater than or equal to sign. It's essentially going to act like an equals sign. So we can add to both sides, we can subtract from both sides, we can multiply, we can divide. The only sort of rule we need to be aware of is if we divide or multiply by a -1 or by a negative number, what we're going to get is the greater than or equal sign will flip and face the other direction. So if we multiply or divide by a negative, it's going to flip that greater than or less than sign around the other way, have a little bit of an impact. This doesn't, there's a negative here, but we're dividing by +2. So this just means our x needs to be greater than or equal to -3. So we can sort of notate the domain that way, or we can again do the interval, right? So our domain of h, so starting at -3 and then anything that's bigger than that. So we're just going to say, okay, -3 to infinity. We're including the -3, right? Greater than or equals to. And then because it's an infinity, we'll use a parentheses. So our domain for h, everything that's greater than or equal to -3, looks like the interval, right? -3 to infinity, where we're including the -3, and we use our parentheses on the infinity. So finding a domain using algebra stuff, algebraically.